So this is the follow-up lesson for graphing trigonometric functions. We're going to stick with, I think, just sine and cosine today. We'll talk about tangent another day, but today's lesson is going to include phase shifting. So I think we're still going to be on our initial notes worksheet for my PreCalc kids, and we're going to talk about the form that is often given to us in our textbook, and then the factored form that I'd rather see it in. Just hang with me because we're going to have a lot of fractions today. So when I'm looking here at this first example that includes phase shifts on our notes, there's -2 in front of the function, the cosine function, and then inside the cosine function we have x over 4 minus pi over 3. So that's what it looks like when you have what's called a phase shift. Sorry, my technology's not working. What's new? All right. Oh, goodness. It's like nothing wants to work today, including me. All right, so we're going to leave the -2 in front of the cosine function. But inside the cosine function, what I need you to do is realize that the x has a coefficient of 1/4. So I need you to factor that 1/4 out. And then think about what you have left when you take a 1/4 out of here. So you're still going to have an x minus, now this is where it gets kind of confusing. You're taking pi over 3 and you're dividing by 1/4. So remember, dividing fractions is like multiplying by their reciprocal. So basically you're multiplying that fraction by a 4. So pi over 3 multiplied by 4 is 4 pi over 3. Oh, goodness gracious. Not a good start. My technology's failing me. And then there's a +2 off to the back end of the function. So that's that vertical shift of up 2. So if I'm trying to identify all these different pieces here, the amplitude is the absolute value of this a, so it's a 2. The vertical shift also happens to be a 2, but you might want to make a little note on your problem somewhere that because there's a negative in front of the function, it has a vertical reflection. The period is still going to be 2 pi divided by b, and now that you could clearly see that the b is a 1/4, that means we're going to take 2 pi and divide it by 1/4, which means 2 pi times 4, so the period is now an 8 pi. And this is where it gets kind of complicated. So the phase shift, x minus 4 pi over 3, remember there's a negative built into that formula, just like everything in math. When you have parentheses in a general formula, there's usually a built-in negative. So that means this has been shifted right 4 pi over 3. Super confusing. So what that means for us is if we were going to graph it, and apparently someone off to the side here already graphed it for our paper, what we would have had to have done then is determined what the quarter points were and then figured out where our initial point was. So if you take your period of 8 pi and you quarter it, so we're finding the quarter point like we did on the last lesson, it counts off by every 2 pi's. But remember, it was shifted right 4 pi over 3. So if I added that right shift of 4 pi over 3 to this, let's see, that's like 6 pi over 3 plus 4 pi over 3, so that's 10 pi over 3 would have been the next point after you started. So if I think about sine, or sorry, this was cosine, my bad, it would have started at right 4 pi over 3, which is this, and notice it's starting at the minimum line here because it was reflected. So then the next quarter point we would have graphed would have been at 10 pi over 3. And it's a little hard to figure out where that is because it's not labeled, but if you think about your fractions, it's right in the middle of 4 and 16. So right here would have been the next quarter point. So next, you can call it a marking or the next quarter point or whatever. So thank goodness someone already graphed this for us because it's kind of awful fractions. So what I suggest to you is, as you're doing these in your work, don't reduce the fractions and think about like what's the easiest way to add fractions. So if you keep having to add 2 pi's to everything, if you don't have a calculator with you, or like it's not quick to grab your calculator, or you just want to challenge yourself and do the fractions, instead of calling this 2 pi, keep calling this 6 pi over 3, because then you have common denominators. You can keep adding 6 pi's over 3's to all those fractions. So good news, someone already did that one for us. So this is kind of a hybrid lesson of we already did part of it on the old lesson, so I'm going to skip over a few pages. Let's look at this one. This one's not done for us. So we have a sine function this time. The amplitude is a 3, and then it is not in factored form. So the first thing I'm going to do is inside the sine function, I'm going to factor that 2 out, and then tell you what's left. So I still have an x instead of theta. They use x on this worksheet a lot. And then if I factored a 2 out of pi, that's like dividing by 2. So that becomes x plus pi over 2. So the period is 2 pi over b, which we just found out was a 2. So it's pi. There is no vertical shift, because it's not a plus or minus anything off to the side. But there is a phase shift, this time of left pi over 2. So I don't know if it's good news or bad news for you, but they already drew the coordinate plane, which I kind of find that to be bad news, because then I have to kind of go with whatever they labeled. So that's kind of irritating. I have to start this function as being shifted left pi over 2. And I'm noticing the way they labeled it, every mark is a pi over 4. Because if this is pi over 4 and this is 0, pi over 2 and that's 0, that's pi over 4. So this is negative pi over 4, which means I really need another mark over here to start off at negative pi over 2. How annoying. Alright, let's mark. Our midline is still going to be at 0, but our amplitude is 3. So we have a maximum boundary for our range and our minimum boundary for our range. I like to mark these in with a highlighter or something before I start, because at least I have a visual boundary so I don't get crazy when I graph. And it is a sine function, so it's going to start at 0 normally. However, everything's been shifted left pi over 2. So that's going to be my new starting point for this sine function. From here you have a couple of different options. So we can do what we did on the last question, where we take the period, cut it in quarters, and find the quarter point. So period was pi. If I cut it by 4, that means I'm counting off every pi over 4. So I can tell by my graph, every pi over 4 is every single tick mark. So I can just start counting off every single tick mark. So that's how I do it. The other option is to find the next marking. You take your initial starting point, which is negative pi over 2, and then you add one of the quarter points to it. So you do have a bit of a fraction issue. Negative pi over 2 is the same thing as negative 2 pi over 4. You need common denominators. So when I add these together, I get negative pi over 4. So that would be my next quarter point. But remember how we said, like, it's just the next tick mark? This is what I mean by that. So once you graph the first one, you can sense a pattern as to how far out you're going to be traveling. So every pi over 4 is going to be your mark. It does say graph 1 period, so once I get this guy graphed in, which I feel like I should hold my breath when I graph this, because I just do such a bad job. Alright, super, nailed it. It's so bad. Then I can go ahead and label the 5 marks that I apparently graphed. So this guy right here is negative pi over 2 comma 0, and this guy is negative pi over 4 comma 3. This is 0, 0. This is pi over 4 comma negative 3. And this one is pi over 2 comma 0. Lovely. Alright, so that skip for today note was yesterday's note. We're not skipping this anymore. Alright, this next one, it is technically in factored form. There's a 1 in front of here for the b, so if you want to think of it as like a 1 came out of this, you can. But we don't have to do any extra factoring. That's the good news. So the amplitude is also a 1. There's a 1 in front of the function. The period is 2 pi over 1, or just going to be 2 pi. There is a vertical shift this time of up 2. And then the phase shift, negative pi over 3 in the parentheses there, means it's been shifted right pi over 3. Alright, so good news, bad news. I'm not sure how you feel about this, but there's no coordinate plane graphed, so you have total control over what this looks like. For me, I like that. I think, I don't know, control freak of me or something, I don't know. So let's say this is a 0 vertical line. Your midline is up here at 2. Total horizontal line I just graphed, right? And then your amplitude's a 1, so it's going to graph up to 3 and then down to 1. so crooked. Alright, you know, for everybody else in the world, you can probably hand draw these, but not for a Brusso. Alright, so if I think about how I want to mark up this coordinate plane, my first point that I graph is going to be that initial shift of right pi over 3. So I'm going to go ahead and mark that as pi over 3. And then I'm going to evenly space out 4 more points, my quarter points. 1, 2, 3, 4. The trick is now I just got to figure out how to label them. So the period is 2 pi. My quarter point is that quartered, so 2 pi over 4, which is pi over 2. So if I think about adding pi over 2's to each of these, common denominators again, right? So this is a 2 pi over 6 plus 3 pi over 6. So that's what, 5 pi over 6? So if I add another pi over 2, which is 3 pi over 6 to that, so 5 pi over 6 plus 3 pi over 6 is, what, 8 pi over 6? I'm going to leave it not reduced, if you don't mind, for a moment. And then adding another 3 pi over 6 would be 11 pi over 6. And then adding another 3 pi over 6 would be 14 pi over 6. Again, I'm going to leave it unreduced for a moment, because look, how hard is it to reduce it? Not too hard, right? This is 4 pi over 3, and this is 7 pi over 3. Okay, so that was actually the hardest part of the question. Now what you have to do is just remember where you're supposed to start and then what the shape is supposed to look like. So this guy, remember, was our initial like origin point that got shifted. So cosine starts way up here at the maximum. And then the next quarter point that we graphed is mid, minimum, back to mid, max. It was misleading when I graphed that little asterisk here. I'm going to erase that. Alright, so that's why I like not having the axes, because then when I go ahead and just draw these mystical quarter points that I know I'm going to have, I can go ahead and label them how I want them to label. Sometimes they give you a worksheet where the graph is already there for you, and all of the axes are going to be reduced because a computer came up with them, and then you're like, oh man, it's a lot of fractions. So, I mean, sometimes it works out in your favor and sometimes not. This is a bunch of stuff we already went over on the other lesson. Alright, so here. They just want you to state the frequency, which is kind of stupid, so let's cross that off and say let's state the period, because who cares about the frequency? The frequency is just the reciprocal of the period, so, like, I mean, it's important to, like, real-life applications, but on these questions it's really not important for graphing. The midline is going to be where your vertical shift took you, because it's usually at 0 unless it's not, like for instance right there. So the period is 2 pi divided by, see how there's a b value we'd have to factor out of there, so 2 pi divided by 1/2 would be a 4 pi, and then the vertical shift, or the midline, would be the function, or the line, excuse me, y equals 1. Similarly here, the period is 2 pi over, there's a b right there, so 2 pi over 3, and the midline, vertical shift, would be y equals -2. Wow. Easy set of questions. All right, this is a nice application, and you're going to see this a lot in our textbook. Music has lots of trig applications. The frequency of a note on a piano, C above middle C, has a frequency of 524 hertz. Cycles per second is what that means. So I want you to write a sine function that can be used to model that initial behavior of the sound wave associated with C having an amplitude of 0.1. So there's the A value. This frequency business is basically telling you the reciprocal of the period, but remember there's a formula on another sheet where if you're trying to calculate the b value, which I don't know why I use capital B, sometimes I do, instead of like 2 pi over period, you can think of it as 2 pi times the frequency, because that's another way to calculate since they're reciprocals of each other. So the b value here would be 2 pi times 524, so if you want to leave it pretty and in terms of pi, that's 1048 pi, right? So I'm going to stick this right in the middle of the sine formula, and because of the way they've notated this function, there's no phase shifting or any sort of vertical shifting here. So I don't really tell us what variables to use, so we'll just say y equals amplitude of 0.1, sine, we just calculated b to be 1048 pi. I was supposed to write a pi there, not 8. And then I do need a variable, so you either have to use x or theta. I'm a big fan of Greek letters, I'm going to use theta. And that was it. That wasn't too bad, right? Here, we're going to write a sine function that has all these characteristics. So, amplitude of 2, period of 4, phase shift of 1/2, and a vertical shift of 4. So the tricky one here is the period of 4 business, because when you're writing a sine function, the b value is what you really need. So another way to think about b, it's 2 pi divided by the period. So putting that information into my formula, y equals amplitude of 2, they said it's a sine function. The b value is 2 pi over period, so 2 pi over 4 would be pi over 2, so that's what goes into the function. And I would love it if you guys, oh, that's not what I meant to write. If you guys could just always leave these in factored form, because frankly the other form is just kind of goofy. So then you can use x or theta. Phase shift of positive 1/2. So in the formula that would be a negative 1/2, built-in negative, and vertical shift of +4. If you really insist on multiplying the pi over 2 into that, go for it. Alright, and again, theta, x, they can be interchanged here because they didn't tell us what to use. So here we have another sine function, amplitude of 1.2. Phase shift. So I guess we're going to assume there's a normal period then, so the b value of 1, huh? Again, x, whatever you want. Minus 3 pi over 2 for the phase shift. Vertical shift of +1. Okie dokie. Artichoke. That was old stuff, old stuff, old stuff, old stuff. Alright, so we're probably going to do 1,000 examples on the next worksheet of graphing and phase shifting. So, you know what? This one looks fun. Let's try this. The amplitude is 1/7. I'm very happy that I don't have a graph because I'm just going to draw a line and call it 1/7. Yuck. This is not factored yet, so I'm going to take the 6 out of it. So we have theta, and then remember factoring out of 6 is like dividing by 6. Oh, that's going to be really ugly. Why would I do this? This is really bad. Alright, minus 11 pi over 36. Wah wah. Oh my gosh. I'm not pleased with myself. Okay. Anywho, we're going to find all the important parts, and then you're going to have to use your imagination for what this looks like, because it's going to be pretty dang ugly. Alright, amplitude is 1/7. The period is 2 pi over 6, or you could call that pi over 3. I'm not really excited about either of those, because I think about the phase shift and how gross this is about to be. While we're at it, let's talk about the quarter point. The quarter point, if I took pi over 3, cut it into quarters, that'd be pi over 12 is what we're going to count by. But I notice, because of the phase shift, as a denominator of 36, can we just go ahead and call this 3 pi over 36? I mean, that's the same thing as pi over 12, right? So, just keep that in mind. And then it's been shifted down for vertical shift. Down 4. Alright, so here's what we're going to do. We're going to cheat. Oh, by the way, phase shift. Right 11 pi over 36. Alright, alright, so we're going to call this midline here a -4, because I want to. Oh gosh, it's so ugly. And then remember your amplitude is 1/7. So this is -3 6/7 totally. This is -4 1/7. If you want to change this to improper fractions, you sure could. That's 27 sevenths and 29 sevenths. Lovely. Remember, it's been shifted right 11 pi over 36. Then I'm supposed to add 3 pi over 36s to each one to get my quarter points. So, man, this is awful. Alright, 11 pi over 36 plus 3 pi over 36 is 14 pi over 36. That does reduce, but I am not going to reduce it. I don't care. Adding another 3 pi over 36 would be 17 pi over 36. That one does not reduce. Adding another 3 pi over 36 is 20 pi over 36. That does reduce, leave it. And this is 23 pi over 36. Wow. Alright, so remember we're graphing cosine. Start at the top. Ugh. You know what? Super bad news. I think this is off of a worksheet that I assigned to you. And if I assign this problem, I'm sorry. Because I think it's from a computer program where like they already graphed it like a coordinate plane for you, so you're gonna have to like make it work. Sorry. That was really gross. So like I said, I don't really care for notes and for homework if you guys reduce your fractions. You might want to consider reducing them on an assessment if it says, you know, to reduce everything. Just do whatever's easiest for you. I'm not really quizzing you on how good you are at manipulating fractions at the moment. So the real exciting part comes when we do the trig modeling, which is coming up next. We have not graphed a tangent yet. That's coming up on a following worksheet. I think we'll just stick with sine and cosine for now, and we'll stick with modeling with sine and cosine next, and then we'll talk about tangent and then some other reciprocal functions coming up soon.